This is our presentation on gut dysbiosis and disease. I'm Hannah Duffy.
I'm Caden Price.
And I'm Erin Ryder.
Examining the disruptions in the gut microbiome and its links to conditions such as inflammatory bowel disease and obesity. So, to introduce the topic, gut dysbiosis refers to an imbalance in the community of microbes living in our digestive system. When everything is working well, these microbes help us digest food, support our immune system, and even affect our mental health in positive ways. But this balance can be thrown off by things like antibiotics, poor diet, or stress, leading to too many harmful bacteria or not enough helpful ones. That imbalance can cause symptoms like bloating, fatigue, or digestive issues. You may not even realize it's your gut microbes that are out of sync. What's even more important is that dysbiosis is linked to chronic diseases. In inflammatory bowel disease, for instance, it can worsen gut inflammation, and in obesity, it may help the body extract more calories than normal. So, although these microbes are microscopic, they play a huge role in our overall health. And keeping them in balance is something scientists are now taking very seriously, because dysbiosis can compromise gut barrier integrity, immune modulation, and metabolic function.
The causes of dysbiosis are influenced by many factors, including genetics, which can influence the structure of an individual's microbiome. Some people inherit traits that make them more vulnerable to microbial imbalances. Antibiotics and other antimicrobial medications are common disruptors. While they're effective in treating infections, they often kill off beneficial bacteria along with the harmful ones. This can lead to a long-term imbalance in the gut. An unhealthy diet, especially one low in fiber and high in processed foods, sugar, and unhealthy fats, can encourage the growth of harmful bacteria while depriving beneficial microbes of the nutrients that they need. Environmental toxins, such as pollutants, pesticides, and heavy metals, may negatively impact the gut by damaging the intestinal lining and altering microbial composition. Aging is another factor. As we grow older, the diversity of our gut microbiota tends to decline naturally. This makes the digestive system more susceptible to imbalance and inflammation. Now, moving on to the symptoms, one of the most common signs is bloating, gas, and abdominal discomfort. This is often caused by excess fermentation and gas production from certain bacterial overgrowths. Irregular bowel movements, including constipation or diarrhea, are also typical. These occur because a disrupted microbiome affects digestion, nutrient absorption, and intestinal motility. Finally, many people develop new or worsened food intolerances. When the gut lining is compromised, digestion becomes less efficient and the immune system may react more strongly to certain foods, leading to discomfort and sensitivity.
In obesity, dysbiosis can do many things. One of the most fascinating areas of gut microbiome research is how it relates to obesity. Dysbiosis, an imbalance in the gut microbiota, may actually play a role in how our bodies store fat and process energy. A 2006 study by Turnbaugh and colleagues found that the gut microbes in people with obesity had a greater ability to extract calories from food. This means that even if two people eat the same thing, one with certain gut bacteria may absorb more energy from it and potentially gain more weight. Obese individuals often have a higher ratio of firmicutes to bacteroidetes, two major groups of gut bacteria. This shift is associated with increased energy harvest from the diet. Dysbiosis can also contribute to low-grade chronic inflammation, which interferes with insulin signaling and promotes fat storage, another pathway to weight gain. This helps explain why obesity isn't just about willpower or calories. It's also about biology, and our gut bacteria may be influencing metabolism more than we ever thought. Understanding this relationship could lead to new treatments like targeted probiotics or dietary strategies to support weight management by restoring microbial balance. And then in IBD, inflammatory bowel disease, um, which includes chronic conditions like Crohn's disease and ulcerative colitis, where the immune system mistakenly attacks the digestive tract. Recent research shows that gut dysbiosis, an imbalance in our gut, may play a key role in triggering or worsening this inflammation. According to Nee and colleagues, people with IBD tend to have a lower diversity of gut bacteria. They also have fewer beneficial microbes and more potentially harmful ones. This imbalance may disrupt the gut barrier, allowing harmful substances to pass into the bloodstream and trigger an immune response. In IBD, the immune system stays on, which causes chronic inflammation. Notice how chronic inflammation is related to both obesity and IBD. While it's still debated whether dysbiosis causes IBD or results from it, studies suggest it's likely a two-way street, where inflammation and microbial imbalance reinforce each other. This has really big implications. If we can better understand and manage dysbiosis through diet, probiotics, or even microbiome transplants, like fecal transplants, we may be able to reduce flares or support remission in people with IBD.
Now I'll be going over how dysbiosis can be treated and managed. In some cases, antibiotics, antivirals, or antifungals may be prescribed to reduce an overgrowth of specific harmful microbes. However, it's important to know, as mentioned earlier, that these treatments can also kill beneficial bacteria, so they're used cautiously. Probiotics are another option. These are live beneficial bacteria that help restore balance by reducing harmful microbes and supporting gut health. They can be found in fermented foods like yogurt and kimchi. Along with probiotics, prebiotics are also important. These are types of fiber that feed the good bacteria and encourage their growth. Good sources include barley, garlic, and asparagus. Beyond, sub- Beyond supplements, most people can help their gut microbiome recover naturally through long-term lifestyle changes. Reducing smoking and alcohol use helps minimize inflammation and protects the gut lining from damage. This creates a healthier environment where beneficial bacteria can thrive and their gut can repair itself more effectively. Improving the diet by increasing fiber-rich, plant-based foods provides important nutrients and energy for good bacteria. These fibers promote the growth of beneficial microbes and help produce compounds that support gut barrier function and reduce inflammation. Managing stress is essential because chronic stress negatively impacts gut function and microbiota balance. Stress hormones can alter digestion and increase gut permeability. Finally, regular exercise supports digestion and gut motility. It helps move food smoothly through the intestines, and physical activity also encourages microbial diversity and has anti-inflammatory benefits, both of which contribute to a balanced gut microbiome.
For our research, conclusion number one, dysbiosis contributes to chronic health conditions. Dysbiosis, a disruption in the normal balance of gut microbiota, plays a critical role in the development of chronic conditions such as obesity and inflammatory bowel disease. In obesity, dysbiosis has been shown to increase energy harvest from food by altering microbial metabolism, specifically an elevated ratio of firmicutes to bacteroidetes has been associated with greater calorie extraction, fat storage, and low-grade inflammation. Additionally, reduced microbial diversity can weaken gut barrier function, allowing lipopolysaccharides from gram-negative bacteria to enter the bloodstream, promoting systemic inflammation and insulin resistance. This means the body holds on to more calories and stores more fat than it should. Even if a person eats a normal amount of food, they may gain weight more easily because their gut bacteria are out of balance. It also means the immune system is constantly being activated, which can make people feel tired, inflamed, or even sick more often. In the case of IBD, such as Crohn's disease or ulcerative colitis, dysbiosis results in a loss of anti-inflammatory species and an overgrowth of pro-inflammatory bacteria. This imbalance triggers immune dysregulation and damages the intestinal lining. The gut's ability to repair itself diminishes, perpetuating chronic inflammation. Inflammation is the body's natural response to injury, but when it becomes chronic, it does more damage than healing. This makes symptoms like pain, bloating, and diarrhea more frequent and harder to control in people with IBD. Emerging research also links gut microbial imbalances to altered bile acid metabolism, short-chain fatty acid productions like butyrate, and impaired mucosal immunity, all of which contribute to both metabolic and gastrointestinal disorders. Thus, maintaining a healthy and diverse gut microbiome is essential for immune regulation, metabolic balance, and intestinal health. In other words, a healthy gut keeps us staying energized, fight off sicknesses, and keeps our digestive tract system working properly. This is why more doctors and scientists are paying closer attention to gut health when looking at chronic diseases. Then for conclusion two, lifestyle and environmental factors are major contributors to gut health. Many things in our daily lives can harm the balance of bacteria in our gut. Antibiotics, while useful for fighting infections, can kill both good and bad bacteria. This makes it harder for gut to stay balanced. Poor diets, especially those high in sugar, processed foods, and low in fiber, don't give good bacteria what they need to grow. When this happens, harmful bacteria can grow out of control, leading to problems like bloating, mood swings, and even weight gain. Without the right nutrients, good bacteria can't do their job of protecting the gut. Age can also affect the microbiome. As we get older, the mix of bacteria or a mix of gut bacteria can change, sometimes in unhealthy ways. Toxins in the environment, like pollution or chemicals in foods, and existing health problems can also throw off this balance. Even common things like artificial sweeteners, preservatives, and pesticides might affect the bacteria in our gut over time. Chronic diseases like diabetes or even frequent stress can also make it harder for gut bacteria to stay balanced. These factors show why it's important to make healthy lifestyle choices, like when eating more fruits and vegetables and fiber-rich foods, limiting antibiotic use when possible, and staying active. Even small changes like switching from white bread to whole grain or adding more veggies to a meal can help support a healthier gut. Over time, these small habits can lead to big improvements in digestion, energy levels, and overall health. Conclusion number three, maintaining a healthy gut microbiome is key to both metabolic and immune health. The gut microbiome plays a major role in keeping the body healthy. When the gut has a good balance of bacteria, it helps control blood sugar levels, manage how to use and stores energy, and supports a healthy metabolism. Certain gut bacteria help break down complex carbs and fibers into short-chain fatty acids like butyrate, which are important for energy balance and reducing inflammation. These short-chain fatty acids also help protect the lining of the gut, keeping pH levels balanced and provide energy to cells in the colon. Without them, people might feel more tired or have trouble digesting foods properly. The gut is also a central part of the immune system. About 70 to 80% of immune cells are located in or around the gut. Healthy gut bacteria teach immune cells to respond properly to threats while avoiding overreactions that can lead to autoimmune diseases or chronic inflammation. This is why the gut this is why a strong gut can help the body avoid allergies, reduce the risk of infections, and even protect against certain types of cancer. Gut bacteria basically train our immune system to be smart and not overreact. When this balance is disrupted, like in dysbiosis, harmful bacteria can take over. This can lead to weight gain, insulin resistance, and ongoing inflammation, which are linked to diseases like type 2 diabetes and IBD. Dysbiosis can also make the gut lining weaker, allowing harmful substances to leak into our body and trigger an immune response. This is called a leaky gut. Leaky gut means that instead of keeping things inside the digestive system, gut lining let toxins, bacteria, and undigested food escape into the bloodstream. This confuses the immune system and causes inflammation through the body. Preventing dysbiosis and supporting a gut health includes eating a fiber-rich diet, like fruits, vegetables, whole grains. Avoiding unnecessary antibiotics. Only use antibiotics when it's absolutely necessary. Managing stress and sleep. Chronic stress and raised cortisol levels, which harm gut bacteria. Getting enough sleep gives the body time to rest and heal. Staying physically active. Exercise not only helps digestion, but also increases the number of helpful bacteria in the gut. All these habits together help protect the gut microbiome and lower the risk of long-term diseases. Gut health really is connected to the rest of the body, from the brain to the immune system.
And these are our sources. Thanks, guys. Go team.